So our integration now will become integration of 0 to 1. Here we have x raised to p minus 1. So this term raised to p minus 1, which is nothing but at the whole raised to p minus 1 upon a plus b minus bt the whole raised to p minus 1 into, then we have 1 minus x the whole raised to q minus 1. So this whole term raised to q minus 1, so which will become a minus b the whole raised to q minus 1 into 1 minus t the whole raised to q minus 1 upon a plus b minus bt the whole raised to q minus 1. After that we have dx term. What is dx? Dx is this term. So we get a into a plus b upon a plus b minus bt the whole square dt, and in the denominator we have a plus bx term the whole raised to p plus q. So a plus bx term is nothing but this term the whole raised to p plus q. So in the denominator we have a raised to p plus q into a plus b the whole raised to p plus q upon a plus b minus bt the whole raised to p plus q. So now we will take all the a minus b term together, all the a plus b minus bt terms together, all the t term together. So we get integration of 0 to 1 a into t the whole raised to p minus 1 will be nothing but a raised to p minus 1 t raised to p minus 1 upon a plus b minus bt the whole raised to p minus 1 into a plus b minus bt the whole raised to q minus 1. When we combine this, we will get a plus b minus bt the whole raised to p plus q minus 2, and when we combine it with this term here, it is square, so it will be plus 2, so minus 2 and plus 2 will get cancelled. So here we have a plus b minus bt the whole raised to p plus q, and this term, that is a minus b the whole raised to q minus 1 into 1 plus t the whole raised to q minus 1 upon this term is combined with this term. Then we have a raised to p plus q, a plus b the whole raised to p plus q, and in the denominator we have this term, that is a plus b minus bt the whole raised to p plus q into a plus b dt. Now if you see, we can cancel this term, that is the whole raised to p plus q and the whole raised to p plus q. Here it is not a minus b, here it is a plus b. So now we will combine all the a plus b term together. So consider this term, and this term. So these three terms are nothing but a plus b q minus 1 into a plus b upon a plus b the whole raised to p plus q. First we will combine these two terms, so this term will be represented as something like this. So plus 1 and minus 1 will get cancelled, so we have a plus b the whole raised to q. When it goes in the denominator, it will be minus q, so minus q and plus q will get cancelled, so these three terms will combine and we will get a 1 upon a plus b the whole raised to p, and here it is 1 minus t, so that's a mistake. This term is combined and we get a plus b the whole raised to p. When we combine a raised to p minus 1 and a, we will get a raised to p, integration of 0 to 1, and now we are remain only with t raised to p minus 1 into 1 minus t the whole raised to q minus 1 dt. So now in this denominator we also have a raised to p plus q, so here it is be a raised to p plus q. When this a raised to p goes in there, it will become a raised to minus p, so a raised to minus p. This minus p and plus p will get cancelled, and in the denominator we have only a raised to q. Okay, and here we have a plus b the whole raised to p. Now if you see only this integration, it is similar to integration of 0 to 1 x raised to m minus 1 minus x the whole raised to n minus 1 into dx, which is nothing but beta of m comma n. So these two equations are similar, so this is nothing but beta of p and q, so it is nothing but beta of p and q. So this is our integration. Now if you compare this equation with our given equation, both these terms are similar, so left hand side is equivalent to right hand side, hence proved. So this is how we solve the problem on beta and gamma function. More such problems we will see in our next video, so stay tuned for our future lecture.